research questions, and then also how to go about developing your research problem. So we did all that, and then you come up with your research hypothesis at the literature review section. So we have done all that. And then the framework. So this is the part that I mentioned on the page that I stated on the page that many of you, I think you are still struggling with the conceptual or theoretical framework. So next week I will devote the whole of next week to go through this with you. So how to develop a good theoretical or conceptual framework. And then out of that, you design your hypothesis. So we'll do this next week. But at least I can see many of you have done your literature reviews, and then you have explained the concepts underlying your studies. And then some of you have even gone ahead to explain the theories supporting your work. Yeah, so I think so far so good. Is there anyone who has a question in this area? I will not answer so many questions because next week I'm going to devote the entire time for this. So if maybe one or two questions on the concepts, I'll answer. If not, I'll continue. Now, we looked at this last week, and this has to do with the research methodology and then the data analysis. And within the methodology, I mentioned that you need to develop your questionnaire, which you have already developed. That's the first thing that we all did from the beginning. And within the questionnaire, there's something that we call the measurement items. So I explained to you that the measurement items, it depends on the statement, your statement or questions that you have. They will determine the kind of measurement items that you put into your work. For example, if your question, if you have a statement about gender, what is your gender? Are you a male, female, or any other gender? And that will fall into what we call a nominal scale. Okay, so the measurement scale or the measurement items, this is what's it's represent. And then if your statement or questions is about ranking, getting to know the level of preference, importance, order, that will be more of an ordinal scale. And then we have the interval scale and then the ratio scales. So I explain all these things to you. Then I explained that in terms of viewing the questionnaire, we have different types. You can completely adopt somebody's questionnaire, like you take almost the same thing that somebody has done, the same questionnaire somebody distributed. You use the same information as yours, and that is called adopted questionnaire. Then we have adapted. Adapted is when you take somebody's questionnaire, you make changes, you either add or take some of the things out of a previous studies questionnaire, and then you use this for your study. That's adapted. And then you can entirely develop your own from the scratch. And that one is called the developed questionnaire. So these are the different types. And we saw this from the beginning. And last week, last week and last 2 weeks, I took you through what we call the research design, the research philosophy. Are you a positivist or interpretivist? Or are you a constructivist or construction? Are you also a realist? What kind of research philosophy underline your study? So all these things were explained. And then I mentioned that based on your research philosophy, to influence your research design. So that will lead you to either you picking a quantitative or qualitative study. So whether your study is a qualitative study or a mixed method, it's influenced by the research philosophy that either you believe in or you take, this position that you take. So I explained that to you, including something that we call the pragmatism. So all these things are there. Okay, so now you have all these things done. You have distributed your questionnaire or your survey. You have received responses, and I guess many of you have received responses at least 20, 30, 50, 100, whatever. You have received responses. What next? The next thing is to do the data analysis. And that's where the structural equation modeling thing comes in, talking about either the PLS or the CVSEM. And that's what we are going to do. So basically, we have two types of structural equation modeling, two types. I mean, currently, even though I have also read that some scholars have put other versions or other types out there, but the two that are very popular in the market among the scientific community are what we call the PLSM, which is partial least square structural equation modeling. And then we have the covariance-based structural equation modeling. Okay, so I'm going to give you some differences and the reason why you have to choose whatever you want to choose. Okay, with respect to the PLSM, one good thing about the PLSM is that it is good for a sample size which is smaller. When I use the word smaller, I will peg my threshold or my limit to 200. If you have responses of 200 or less, the PLSM is good for you because it can accommodate a smaller. And don't forget the rule for quantitative studies, most of them is that at least you must have a data set responses of at least 30 or more. So in terms of smaller, when I say smaller, I'm talking about between 30 and 200. The PLSM can accommodate that. But if you want to do an analysis that you have more like 500,000, then the CVSM is better. I'm just trying to give you some differences, but it doesn't mean that they work strictly as, because the PLSM too, somebody can also analyze PLSM where the person has about 1,000 responses using PLSM or 500 responses. It can work. So it's not like a strict rule, but these are some of the things that will make you choose one over the other. Then also with respect to the PLSM, it can accommodate a number of variables. So when you are dealing with different variables, and variables, I'm talking about the latent variables or the constructs, you are dealing with a lot of them, the PLSM is better compared to the CBSM. Another difference is that the PLSM accommodates a study that you are trying to develop a model, or you are trying to use either a model or a theory, let me put it that way. While the CBSM is good to test an established theory, the CBSM, if you already have an established theory, which it's already been established or you have established, then it's better you go for the CBSM. Another difference is that the PLSM is good for non-normal data set. And when I say that non-normal, I'm talking about the distribution of the data set. If your data set is not normally distributed, and remember we went through how to run normal distributions. You can use the Shapiro-Wilk test or Kolmogorov-Smirnov. If you check your data set and it's not normally distributed, then it is good you use the PLSM. But normally the CVSM is good for normally distributed data sets. So these are some of the differences. But once again, as I said, it's not like a straight through, because I mean there can be overlaps, and then sometimes some of the indicators that we look at, you may not get all of them. You may get one, then you just use it, or you may get 2 or 3 or 4, depending on the situation. Or sometimes even one of the indicators will be defeated or will not stand, but you still have to go ahead and run the data set. Okay, good. So in this analysis, or what I'm teaching you, our work is concerned, I will take you through the PLSM. And the reason why I'm going to take you through the PLSM is that what I've noticed is that most of the data set that we collect, or most of the data set that people collect using questionnaire, at the end of the day, they turn out to be non-normally distributed. At the end of the day, in my experience, that doesn't mean that it's always the case. So I'll take you through that. But in the second class, starting from September, I will take you guys through the CB-SEM. Yeah, but as far as this class is concerned, we will complete the PLS. Yeah, then the second part will go through the CB-SEM. Okay, good. So when you are presenting your results, your paper, or when you are writing your article, and you get to the methodology section where you are explaining the data analysis, you need to explain why you have decided to choose the PLSM over the CBSM. And that's what I've done with you right now. Or if you decide to go for the CBSM, explain why you think the CBSM is preferable to the PLSM. So any of them that you decide to choose. Yeah.
So I raised my
Yes.
hand since it's like I'm moving forward. So I'll just ask a question.
Yeah, ask.
If the data is normally distributed, is the analysis that we used to see. And then you made mention of the Shapiro and then the Kuska Wallace.
Yeah.
I want to ask how is it, if a data is normally distributed, is it by analysis or by you, the researcher you experience?
No, it's by analysis. No, as far as, okay, good. That's a good question. So when you get to this point, I want to advise that don't make any decision based on your gut feelings. Okay, it's not ideal. It's not the best as a researcher, as a data scientist. It's not an ideal to always, to make decisions from your gut feelings, especially where you have the data with you. It is good you back your decisions, you back anything that you put out there with data or with analysis or with results. So I will advise that whether you choose to go for PLSM or CBSM, and your base, and if your base is going to be like, let's say, normally distributed or it's not normally distributed, there must be some resource. There must be something that you have run to show that indeed the data set is not normally distributed or the data set is normally distributed. So don't just say it. Show us or provide evidence of why it's not normally distributed or why it is normally distributed. Yeah, so that's the best approach. Yeah, I get this because sometimes some people will just say that, okay, based on so and so, I think this thing is so, but as far as quantitative research is concerned, it is good you always show evidence. And that evidence, I'm talking about the results from the data that you have run or something. Yeah. So that's the best approach. Don't just make decisions based on your gut feelings. It's not the best. It's not the best. Even in qualitative studies where opinions and experiences are welcomed, we still have thresholds and we still base on certain things. So evidence is important as far as quantitative research is concerned. And that evidence, I'm talking about results that you have run. So for example, with the normality test, you can use Shapiro-Wilk test. You run it, get the results, and based on the results, you decide that, okay, so I ran this, I got this, and based on this, I'm going to use CBSM or PLSM. So there must always be something to support your decision. I hope Emmanuel is okay.
Please, what are the thresholds for you to know that this data is not normally distributed or distributed?
So if you want me to answer that question, I will just refer you to some of the videos I've made. You go back and check the Shapiro-Wilk test. I have a video on it. So you can run that in SPSS. You can run that in Starter. You can run that in even the Smart PLS. You can run it. I wish I can do that, but unfortunately, if I decide to do that, I have to take everyone back. And then we have to come back again. It's a long process. So the best thing is go to the channel, check Shapiro-Wilk test. It's there. Just watch it. I think it's about 20 minutes or so, 30 minutes. How to get that. Once you run your data set and you get the results and it's normally distributed, then you decide. If it's not normally distributed, you decide the other way around. Yeah. Emmanuel, is okay?
Yes, Doc. Thank you.
Okay, you're welcome. Okay, so this is what I was talking about. So here, you get to the data analysis and you just give a brief explanation of what method. So always when you are explaining the data analysis, you need to mention the method that you are using. Like, are you using the PLS or you are using the CB? So here I mentioned that I use a PLSM and I give reasons why the PLSM is better than the CB. Okay, so I've given the explanations here. So you have to do the same. So if you decide to go for the covariance-based structural equation modeling, you need to give reasons why it is better than the PLSM. Then you go ahead to explain. Without wasting too much time, I'll go straight to the analysis. So now let's assume that we have decided to go for the PLSM. What do I need to evaluate? Or what do I need to do? Okay, good. So for you to make sure that you have done a proper PLSM, there are two models that you need to evaluate. The two models are, one, we have what we call the measurement model, and then we have the structural model. These are the two. So two models that you have to run. So I'm going to help you out why you have to run these models. Okay, good. So one, the measurement model helps us to know the relationships between the indicators and then the construct. So I want to take you back because we did this some time ago, and I guess some of you either you have forgotten or you are a bit you have not revisited it since we did this. So this is what I'm talking about. This is what I'm explaining. This is what I'm talking about. So here you can see the latent variable 1, latent variable 2. So these are what we call the variables or the constructs. What are they? The constructs are the main things that you are trying to deal with or you are trying to assess. So for example, if I'm looking at maybe the relationship between artificial intelligence and employee performance, artificial intelligence, which is AI, and employee performance, my two main constructs here are AI and employee performance. So with these two latent variables, I need to have indicators. The indicators are the things that will help me to know that, yes, AI is either used, is important, is adopted, all sort of words that you want to use it for. And the same thing applies to the employee performance as well. So with the latent variables, you need to have your indicators. Sorry, I need to get some water. So with the latent variables, you need to have indicators. And if you remember from the beginning, I explained the indicators to you. The indicators are the things that represent or come together to form the latent variable. Okay, so let's take something like artificial intelligence. What are some of the things that we can use to represent artificial intelligence? Many of them. Maybe we can say that artificial intelligence help us to do our work easier. AI is cheap compared to other forms of technologies. AI is what? Other things that you can say. So they will present what we call the indicators. But even the indicators, remember that I explained to you that we have two types. We have the reflective and then we have the formative. But I will not go into that because that's not important as far as this thing is concerned. So that's it. Now let's take another example. So let's assume that you talk about technological factors, economic factors, political factors, social factors, legal factors. Let's take something like economic factors. Economic factors, some of the indicators. So the economic factors will be the latent variable. What are some of the indicators? Inflation, interest rates, unemployment. So these will be the indicators. If you take political factors or the issue of politics, you can talk about what? Political instability, democracy, free speech. These things will form the indicators. In other words, these things either represent or come together to form that latent variable. I hope you get that. Good. So when you try to look at the relationship between the indicators, the relationships between the indicators and then the latent variable, we say that you are doing a measurement model assessment. So let me give you one example. Another example again. I mean the same thing. Economic factors. The economic factors we are talking about: interest rate, inflation, unemployment, what business, the number of businesses set up, and so forth. If you look at these indicators and their relationship with the variable called economic factors, if you try to assess the relationship between them, we say you are doing a measurement model assessment. That's the first one. Then we go to the structural model. With a structural model, you try to look at the relationship between the latent variables. So, for example, if you try to look at the relationship between economic factors and political factors, AI and employee performance, what? Social factors and legal factors. You look at the relationship between these latent variables, we say that you are doing a structural model assessment. So let this diagram be in your head. Just put this in your head. So I'll just take you through what evaluation criteria, what do you have to assess, or what do you need to know when you are undertaking a measurement model assessment. And to make it easier, because I think some of you, the things look a little bit abstract. I have something here from my PLSM. I think that will be good. And I want to see that nobody should download this model. I will let everyone download this model after the last meeting. Yeah, after the last minute. And when I say the last minute, I'm talking about after I've taken you through the conceptual and theoretical framework development, which is next week. So nobody should download this because in your case, I want you to use the free trial. And the free trial, it takes 1 month. So if you download it now and install it now, by the time that maybe we will start the analysis, a number of days have gone. So you may have to purchase it. And I think many of you will not be able to get $100 and $200 to purchase that. So we are all going to use a free trial. So nobody should download it. When we are ready, when you are ready, when your data is ready, when everyone is ready, I'll let everyone download it. We'll all do it here and we'll all run our work together. And from there, I'll let you go and play around it. So let's look at it. So here, can you see what is on my screen? So this ATT, the blue ones, all the blue ones are the ones that we call the latent variables, also called the constructs. The word construct is the same as latent variable, also called unobserved variables. All the blue circle, the blue ones, these are the main variables that we are trying to analyze, or we are trying to work around it. And then the yellow boxes, whether boxes or rectangle or whatever you want to call it, the yellow ones, they are called the indicators. The indicators. In other words, if you take each of the round circle, the things measuring them are this. The question that somebody will ask is, so is it always, are they supposed to be 3 always? They are not supposed to be 3. In this case, the person did 3, but let me show you another one. Because it seems that maybe somebody will get a wrong impression that the indicators are always supposed to be 3. It's not so. I just want to show you another. Yeah, so I think this is better. So that wrong impression will be taken out. So you can have as many as indicators as you can. It could be 2, it could be 3, it could be 5. There are even situations where some indicators are only 1, the yellow rectangular boxes. Okay, so you can have many indicators. That's what I'm trying to say. Many indicators. So you can have many indicators. Just a minute. So you can have many indicators. Good. So these indicators, they represent, or they reflect, or they form, whether you are looking at it, they form this. Without these people, these things will not be there. Who's coming in? Okay. Without these indicators, the blue ones will not be there. I hope you are getting my point. Without these indicators, the blue ones will not be there. Okay, so now you have this. And when we start running, I'll take you through how to form all these things. It's easy. Very easy. This is interface friendly. Like, it's easy to work around it. But just that for now, I'm not going to start from the scratch. So you have this. Then you run. You run your model and you get a resource, right? So the relationship between the yellow rectangular boxes and then the blue circle ones, when you try to look at the relationship between them, you can see some numbers here, right? That is what we call the measurement model assessment. Measurement. model assessment. The relationship between the indicators and this is called measurement model assessment. And in trying to look at the measurement assessment, there are certain indicators that will help us to know whether you have done the right thing or you have not done the right thing. So one of them, which I want everybody to take note of it, is what we call the indicator reliability. That's the first one. Indicator reliability. Indicator reliability. How do we determine the indicator reliability? You determine that using what we call the factor loadings. The factor loadings. The factor loadings. So here, for example, the factor loading between OE1 and then the main OE is 0.858. And this one is 0.920. Okay, so the question then is, what is the acceptable threshold? And that's what I want everybody to take note and write it down today, because I may not revisit this, or even if I will visit this again, I will visit it when we start running your data. There's a threshold, there's a cutoff point for each of them, and I'm going to give them to you today. So the reliability, the indicator reliability, which tries to measure the relationship between the indicators and then the constructs, the cutoff point is 0.7 and above. 0.7 and above. If you get 0.7, 0.75, 0.8, 0.9, 0. something, 0.8, that means your indicator is reliable. That's what it means. Okay, your indicator is reliable. Your indicator is reliable. Is there a question that somebody wants to ask? That means your indicator is reliable. That's the first one. Is that okay? So it's just trying to help us to know how the indicators are representing the construct. Are they representing them well, or they are not, in terms of how strong they are, or how, like, let me give you an example. Like, if, let's say your I mean, it's just a little bit of parental issue, but let's say that you go somewhere and somebody pass a comment that, as for this child, he acts and behaves just like his or her parents. As for this child, he just behaved like his or her parents. Like if you take Sharon, or if you take somebody like Mubarak or King, say that, oh, okay, as for King, he just behaved like his parents. It's an indication that, one, either your parents have raised you well, or opposite, or something else. I mean, that's not a practical example. I'm not saying that it's supposed to be so. I'm just an example. Yeah. Showing how you represent them. As for this child, he really resembles his father. Like, he behaves, he acts just like his or her parents. So it could be good, it could be bad. It could be like you represent your parents in a good way, or you represent your parents in a bad way. Okay, so how the indicators are reflecting or forming the constructs is measured by what we call the indicator reliability, and that's when we look at the factor loadings. Okay, good. So the threshold is 0.7 and above. So what about if I run and I get 0.6 or 0.5? What do I do? That's the next question. So two things. If maybe it is one out of the blue, or out of there's one, or is the one odd out. If maybe you have many indicators, let's say you have 10 indicators, 5 indicators, 6 indicators, and there's one that is having a factor loading of 0.6, 0.7 less than 0.7, 0.6, 0.5, 0.4, then you can consider taking it out. And in most cases, it's recommended that you take it out. In other words, you have to delete it. You have to delete it and rerun your model again. So you delete one, you can delete, like here, you can easily delete. I can delete one of these indicators and then rerun my model again without that indicator. And I'll get a different results. So that's the recommendation. So that's the first one. So what next? The next item to look at is what we call the Chrombat Alpha. You can also use the Chrombat Alpha. Let me use this result so that we get a better. You can use what we call the Chrombat Alpha. And what is the Chrombat Alpha for? Chrombat Alpha helps you know the internal consistency. It measures the internal consistency. Okay, so this table is better. Then this table will help us better. It helps to measure the internal consistency of the indicators, how the indicators relate very well, and they are representing or forming the latent variable. What is the threshold here? So here too, 0.7 and above is recommended. So with the smart PLS, if you are using a smart PLS, if you get anything less than 0.7, it will highlight it red. If it's less than 0.7, it will highlight it red. But if it's more than 0.7, it will just be okay. So all the green ones are okay. Okay. Then we also have other indicators such as composite reliability, and then the average variance explained, AVE. All these things measure what we call the convergent, or all these things help us to know what we call the convergent validity. And what is the threshold? The composite reliability to the threshold is 0.7 and above. What about the AVE? The AVE to 0.7 and above, but in most cases, it's recommended that you can use 0.5, the AVE. 0.5 is also 0.5 and above is accepted. Okay, I think I have done a better explanation here. So this 0.7, 0.7, 0.7, the AVE, the AVE 0.5 and above is accepted, but 0.7, 0.5 accepted, yes, can use 0.5. Now we come to another evaluation or measurement criteria for the measurement model. It's called the discriminant validity. That will help us to know how the construct or the latent variables are not the same, or they are different. So discriminant validity specifically measures whether constructs that theoretically should not be related to one another are in fact unrelated. We are trying to check whether our latent variables are not related. And how do you check that? You can use three measurement items or indicators. One of them is called a funnel and lacquer, or funnel lacquer. You can use the ATMT, heterotrait, monotrait. You can use the cross loadings. With a funnel lacquer, you just take the square root of the AVE. Remember the AVE, this AVE, let me take you to the, you just take the square root of this. And normally comes in the form of a table. Let me show you one. This. Okay, good. So what again do we need? So these are the things that will help you to know whether your measurement model is okay or is not okay. So then maybe the question that somebody will ask is, so what about if I do this and I don't get all these thresholds? What next? If you don't get these thresholds or some of them, it's not compulsory that you have to get all of them. Let me give you an example. Like, it's not compulsory that you have to, all of them must meet the threshold. If you get all of them meeting the threshold, perfect. That's great. That's what we are all looking for. But at least, I would say many of them must meet the threshold. Many of them. There's nowhere when you come to a point where all your measurement evaluation criteria, none of them meet the threshold, then you need to revisit your data set and do something about your data set. Maybe there's something wrong somewhere. So, for example, if you take this one, for example, I will still keep the alpha and then the PR, even though they have combat alpha and composite reliability, which are less than 0.7. Because if I check the other composite reliability and then the AVE, they are okay. So it's not the case that like all of them, but one must be there. But in a situation where you have so many constructs, and then many of the indicators, measurement, evaluation criteria, you are not meeting them. Let's say you have 10 constructs, and then the evaluation criteria, many of them are failing. Then you have to consider removing them from your work. You can consider. Okay, so that's the first one. Any question on this? That's the first measurement. Now we come to the second measurement, which is the structural model. So once your measurement model is okay, now you move on to the structural model. What is the structural model for? The structural model, the main purpose of the structural model is to look at the relationship between the blue box or the blue circles. So here we have moved from trying to look at the relationship between the yellow and then the blue. We are moving from here, and then we are coming to trying to look at only the relationship between the blue ones, which we call the latent variables or the constructs. That we look at the relationship between this. To look at that relationship, we measure them through what we call the structural model assessment. So within the structural model, just like how we went about it with the measurement model, there are indicators to look at. One of the indicators is that, one, you have to look at the multicollinearity between the constructs. And how do you measure that? You can look at the multicollinearity by looking up to what we call the VIF. So you look up to that, and then you use that to measure. Then another thing that you can use to measure is that you can look at the effect size. You can look at the effect size. I'll take you to the PLS SEM very soon to show you. That's the second one. You can look at the effect size. Then you can also use what we call the R square. Also use the R square to check. You can also use what we call the adjusted R square. adjusted R square. Okay, so let me give you a little bit of explanation with the structural model. The structural model actually work just like a normal regression. So many of you, if you have run a regression before, and I guess many of you have done it before in the past, when you run a regression, you see the R square, the adjusted R square, and the rest. Or if you have run ANOVA before, you have seen the F statistic and the rest. The structural model worked just like that. And that's the reason why when we began this whole structural equation modeling, and I told you that the structural equation modeling combines three separate models. The three separate models are: one, a combined factor analysis. There's a factor analysis aspect of the structural equation modeling. There is also the regression part of it, which in a normal sense work like path coefficient analysis. And then you have your path analysis. So the factor analysis, path analysis, and then the regression part. So they all come together. And even there's also an aspect of descriptives as well. The structural equation model, there's also descriptives. So they all come together to form that. So if you have run regression before, I guess you have come across all these things: R square, and then adjusted R square, and the rest. You have also seen the coefficient, the P square, the T square, sorry, the T statistic, the P value, the T statistic, the significance level, whether it's 1% significance or 10% or 5%. So all these things, they are the same. Okay, so one, check the VIF to check the multicollinearity, and then check the effect size. You can also check the level of prediction, the predictive value, or the extent of predictive significance of the model. You can also check that in the PLSM. And others. Others, I mean, there is a way to validate. There's a quantitative way to validate your data using the PLSM. But I'll show you this only when we start running the data. Yeah, I'll show you how to do that. So validate. There are two forms of validation. You can do qualitative validation, you can do quantitative validation. So I'll show you how to do quantitative validation using the structural equation modeling. Okay, good. Now there is another part which I want to introduce you to, and I know some of your studies you have that in there, and that's what we call the mediation and then the moderation. So with the mediation and moderation, it's not something entirely different, or it's not something different, totally different. It's almost the same thing as doing the normal the normal PLS, but just an introduction of some variables and how you structure your model. So if you run something like this, like where the factors are distinct, they are different, and they are measuring performance, this is okay. But I can introduce a relationship which can link one to the other and make one become a mediator. Some will become mediators, and some will become moderators. So without wasting time, I want to take you back to this. So if you check this model very well, as you can see from here, this blue one, they are called moderators. They are moderating the relationship between the variables. And then I have another one on mediation. Let me show you the mediators. This one. Yeah, so this is an example of a mediator. So, for example, if someone is here and the person wants to move to this part, the person has if it's a person, let me put it as a person, the person wants to move from here to this place, the person has to pass through this, has to pass through a middleman, a mediator, and an intermediary. Okay, so in structural equation modeling, we call this one a mediator. And then when you analyze, you just do the analysis, we call this mediation. And then we have the moderators. And then we also have the moderators. Let me give you examples so that the whole thing will make it easier for you to understand. For example, if you have, let's assume that you are you are trying to do a new marketing campaign, right? And your aim is to increase your sales. How do you go about that? What you can do is that you have to do either you brand your product or you do what we call brand awareness. So in this context, the brand awareness will become your mediator. The sales is what you are trying to increase at the end of the day, and that's your dependent variable. And then the exposure to a new marketing campaign will become your independent variable. So a new marketing campaign will increase brand awareness, and increased brand awareness will lead to higher sales. Now let's take a moderator: customer satisfaction, customer loyalty, customer income. The relationship between customer satisfaction and customer loyalty might be weaker for customers with higher incomes. Examples. Okay, once again, these things we'll go further into them once I get your data. At this point, our time is up. Any question? I'm going to take questions then. The next 5 to 10 minutes. And then we move on to.
Okay, Doc. Thank you, Doc.
You're welcome.
Doc, please, one question.
Okay,
So,
ask.
I'm working with only one, let's say, construct. I'm working with barriers of blockchain technology, and I have 36 variables.
Okay.
So now, Doc, please, can you hear me?
Yeah, I can hear you. Go ahead.
Yes. So I'm working with the barriers to blockchain technologies.
Yeah.
So, and then now you are saying that the same, you have to group them into latent variables, which are the constructs.
Yeah.
And so this one, you see, you use at first, you taught us how to use the factor analysis. So this one, are we using our own, maybe understanding to group them, or we have to do factor analysis before you group? We extract such construct, you know that, oh, maybe this indicator belongs to this construct, this indicator belongs to this construct. Or we are supposed to do it on our own.
Okay, that's a good question. So to answer this, there are two ways to go about it. The first one, with respect to, for example, your case, which I know your questionnaire, it will be great you conduct an exploratory factor analysis first. Because in your case, we don't know, you don't know, I mean, like now we don't know which factors belong to which factors belong to which group. So in your case, it would be great if you conduct an exploratory factor analysis. And based on that, we know the groupings. And based on the groupings, then we can assess the relationships between them, the PLSM. Another way to go about this is to group the variables. once again, with your questionnaire, the variables or the factors can be grouped, and you can group this based on past studies, which I'm like, when I say past studies, I'm talking about existing literature. Because, for example, if you take something like inflation, interest rates, all things being equal, studies that people have conducted over and over and over and over and over again shows that interest rate, inflation rate, they all belong to economic factors. So if you group them under economic factors, you haven't done anything wrong. And if you do that, then you have to go ahead and conduct another form of factor analysis called confirmatory factor analysis. So if your groups have already been done, the groupings you have already done the groupings. You know the groups. This belong to this belong to that, based on past study. Then you still have to go ahead and confirm. You still have to go ahead and assess them, whether indeed the factors that you have grouped based on past literature, the variables belong to where they belong. And that is called the confirmatory factor analysis. You have to conduct confirmatory factor analysis. Okay, you have to conduct that. But in a situation like yours, where it seems the factors are scattered, you check the literature, it seems there's no one who has done any groupings, or nobody has put them into groups and all that. It would be great you conduct exploratory factor analysis. And then exploratory factor analysis, the SPSS software or any software that you use will automatically give you the groupings. And then based on the groupings, when you put the names on, you go ahead and assess them. Yeah, so in your case, for example, I would suggest you do exploratory factor analysis first. Go back to the SPSS, conduct exploratory factor analysis, get the groupings, give them names. Once you have the names, come back to me. I'll teach you how to look at the relationships between the groups. And the groups here will form what we call the latent variable, the construct. So the groupings, the names of the groupings, or the groupings will become your latent variables. Yeah, so that's how you go about it. I hope you get that. But I know many others, apart from, I mean, I'm just trying to extend your answer. I know others whose questionnaires, they have already grouped their factors already. Like I know one of you who is doing something about technology adoption or something, like AI, something. And for that person, all the indicators have already been grouped, or they come under certain latent variables. For that, you just go ahead and conduct the confirmatory factor analysis. Confirmatory factor analysis is actually within the PLSM, which is the smart PLS. Conduct that check. You are just assessing. You are just assessing to know whether the variables that are are representing the construct, they indeed belong to the construct or they don't belong. So you need to assess that. Yeah. So Emmanuel, in your case, I recommend you first do exploratory factor analysis. Do that first. And get to know the groupings, because I even decided to check. I checked the other day to see whether there's anybody who has done any study grouping the variables that you presented to me, but it seems nobody has done something like that. There's nothing like that. It's not there. So it is great you do exploratory factor analysis to start the whole thing, and then go ahead with the PLSM. I know some scholars argue against that, but in recent times, most of the studies and papers I've read, they recommend that you have to do exploratory factor analysis, because in the past, many scholars were more of if you want to conduct a SAM, then all your indicators must be grouped, like all indicators must be known. You have to know them. You have to know where they belong to, the construct that they belong to, before you start running your SAM. But in recent times, many of the papers I've read, they recommend doing an exploratory factor analysis if it's the first time that the factors are going to be used. So it's allowed. What I'm trying to say is that it's allowed. Emmanuel, you can run exploratory factor analysis first. Get to know the groupings, and then you can give them names. And then once you give them names, you bring them into the smart PLS, and then we run to check the other indicators. Other indicators I'm talking about to check the structural model indicators and then the measurement indicators. Okay, Emmanuel, is your question answered?
Yes, Doc. Yes, Doc. Thank you.
You're welcome. Any other person with a question? Finn. Okay. Tokin has a question. Yes, if you have a question, please raise your hand. You can talk. Yes.
Hello, Doc.
Yes. Go ahead.
I wanted to know the factor analysis. Is it only the SPLS that can do it, or you can use other data or any other software to do it?
The factor analysis, the good thing about the current version of a smart PLS is that there's a feature in the current this software I'm showing you. You can run your factor analysis here. Yeah, there is a feature that can help you to. This is the one, the factor analysis. Can you see this?
Yeah.
Yes, and can also run the PC. The PC is a exploratory. That's the principal component analysis. So the current smart PLS 4, you can run your factor analysis here. So you don't need to run the factor analysis in SPSS. Say aside the SPSS, the other software that you can use to run factor analysis. So factor analysis is not only done in SPSS. There are many software that can help you. And the good thing is that the current smart PLS, the one that we are using for the PLSM, the originator or the founder, they have updated it. It used to be, because when I started using PLS, I was using, I think, version 2 or so, smart PLS version 2, version 3, I think, something like that. But and at that time, when I was using the version 2 or 3, there was nothing like factor analysis in the PCA. But the current version, which is smart PLS 4, we have updated it. They have added the factor analysis part of it in there. So everything is here. In addition, they have even added something like regression. If you want to run a normal regression, instead of going to buy stator, you can run your normal regression in the smart PLS. So there are so many things that the guys they have added, and that make this thing stand out compared to other software. Yeah. Thomas, are you okay?
Yes, Doc. I'm okay.
Okay. Thank you. Any other person with a question? Sharon. Oh, good. And Debbie. And then also
Yes.
Eugenia. Okay, so there's another thing that we'll do, but all these things we can only do that when we get the data. We look at the importance performance map analysis, and then the PLS predicts. So we'll do all these things once we get a data set. Okay, so we'll do all that. Good. So let's try and get a data set ready, and then we all do this thing together. Okay, on that note, if nobody has a question, I'll bring the meeting to an end. And wish, or there's somebody who has a question. Alphonsus.
Hello, Doc. This is Kid. I asked you to
Yes.
send me a paper. I tried downloading it, but my UG account is not giving me access on Emerald. So I don't know if you can.
Okay, okay. Yes,
Thank you.
I'll send it. I'll send it.
Thank you.
You're welcome. Okay. Thank you. Any other person? I think somebody has raised a hand. Who is that?
Doc,
Yes,
please,
Sharon.
the
Yes.
question is, what if you are not able to get to the 200?
Yeah, if you are not able to get 200, we can still run. But the reason why I explained this thing from day one. The reason why I mentioned everyone should get 200 is the issue is from two things. I mean, and all these things are based on my experiences. One, when you are using a data set which is like fewer or smaller, a lot of reviewers tend to have a lot of questions and issues with you. They will ask you so many questions, and quote unquote, they think you have not done enough. I mean, that's how I see it. That's my personal understanding. Because, for example, you are interviewing, let's say, bank customers. You are surveying bank customers. You are distributing bank customers in Ghana. Look at the number of people who do business with banks in Ghana. Many. So if you at the end of the day you are conducting a study and you just go and pick 20 people or 50 people, people will have issues with you. And I mean, they have a point. All things being equal, that's not from even statistical point of view. I'm talking about general point of view. You are conducting a study of bank customers in Ghana. There are thousands of bank customers in Ghana, and you get only 20 people. And these 20 people is not like maybe bank customers who are like top managers or influential people. We are talking about just normal, and you couldn't get 50 or 100 or 1,000 or something, then there's an issue. So normally, reviewers, including myself, if I see your work and I look at the sample size, first I'll look at the population, I'll look at the sample size, and it's not big enough, I'm going to have issues with you. And that's the reason why I recommended that 200 is feasible, is good. That's the first one. Then secondly, statistically, when you have more responses or the larger your data set, the better. Because it has a way of overcoming some of the statistical errors and biases. The bigger the data set, the better, statistically. So these are the two reasons why I mentioned 200 or more. Because what I have come to notice is that when you are doing any statistical analysis and your data set is smaller, you tend to have some results which are either not good enough or not statistically significant, or you are going to have a lot of issues. That's the reason why some of you in the past, you ran certain data. If you remember, some of you came to me, you ran certain data and you are getting repeated the same results. Like Emmanuel kept on coming to me. And one of the reasons why that thing was happening was that the sample size was small. The sample size was small. If the sample size was big or the responses was big, those issues that we're having, we're not going to have it. So I recommend that you do more to get more responses instead of relying on a small data set. By the end of the day, anyway, the PLSM you can still use the PLSM. After the PLSM, you can even use 40, 50, 70, 80 responses to run it. It will still work. But the larger, the better. The larger the responses, the better. The larger the data set, the better. And as I also mentioned, not to have issues with reviewers, because reviewers are going to ask you a lot of questions. And I've received many questions from reviewers in the past. Like you are saying that you are construction professionals in Ghana. There are so many construction professionals in Ghana, many thousands. Even some of them, they are running into millions. And you go and take 20 people or 50 people, everybody will question you. It's like you have not done enough. Either you are not pushing, or I mean something like something like that. Even though yes, I understand that there are challenges in terms of sometimes reaching out to people. It's true, reaching out. But in a situation where you can do more, if you have the opportunity to do more to get more, I think you have to do it instead of just saying that, oh, I've had 20, so I'm okay. And it's not the best. Yeah, so that's my answer to that. But at the end of the day, if still you push and push and push and push and push, and you are not getting the number, let's say you are looking for 1,000 or 500 or 200 or something, you are not getting, and you have received a sizable good amount, then that's okay. We can still go ahead and run the data. Yeah, but still try and push if you have the opportunity. Push and get more. Okay, Sharon, is it okay?
Yes, please.
Hello? Okay, thank you. Any other person? Any question? Okay, I think we'll end here. Thank you very much for coming. See you next week. So next week we'll cover the last, that will be the last class before we run the data, and that's going to be, we'll go back to focus on developing hypothesis. How do you develop your hypothesis? How do you draw your conceptual theoretical framework? So that's going to be the focus next week, and that's the last class. And then we'll have 2 more classes, and the 2 more classes will be running the data, and that's where we'll use the PLS, and that will be the end. So I want to encourage you that use the next week or 2 or 3 to get more responses. Whatever you can do to get responses for your questionnaire, do it. Do all that you can to get responses for your questionnaire, because we are going to use, everyone is going to use, you're going to use your own data. It's not somebody's data. I will not send you any data set. It's your own data set. Your own data set is for you. So do more to get more. That's what I would say. Thank you very much for coming, and have a blessed weekend. See you next week. Bye-bye.
Thank you, Doc.
Thank you.
Bye. Bye.
Thank you so much, Doc.